Hello students, in this video I will take one example problem and explain the conversion of ε-NDFSM to DFSM. Let us take an ε-NFSM as shown in this diagram here on the slide. We know that this is an ε-NFSM because it has got epsilon transition in it. This ε-NFSM has to be converted into its equivalent DFSM. I will consider a note here, that is delta E represents the transitions for an ε-NFSM. The first step is to identify the start state for the DFSM. Now, here we can see 0 is the start state of the ε-NFSM. And we know E closure of, or E close, we can write it as E close of this start state 0 is equal to the start state of DFSM. What does E close of state 0 tell us? E close of state 0 tells us that we have to calculate all the states which are reachable from this state 0 on an epsilon transition. Here we can see that there is only one transition for state 0, and that is on input A. It goes to state 1. Therefore, E close of 0 is state 0 itself. We will call this as state number A. The second step in the ε-NDFSM to DFSM conversion is to compute the transitions for the DFSM. We already saw that the start state for DFSM is state 0, and we call this state 0 as state A. So from this state A, we will continue to compute all the other transitions. Now before we compute the transitions, what do we require? We require the input set. And what is the input set here? So you can see an input alphabet A, then we can see a B. Here it is epsilon, here it is epsilon, epsilon. Here it is epsilon, here it is A, here it is A, epsilon, 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 epsilon. So we can see that we have got only two inputs, that is A and B. Rest all are the epsilon transitions. Okay. Therefore, now what do we do next is, from on the start state or the state 0, on the start state 0, we take all the transitions, we compute all the transitions. So consider state A. And we know state A is 0. Now we calculate the delta D transitions. Delta D of state A, comma A, because we are taking the first input, is equal to E close. We know that in ε-NDFSM we have a E closure concept, and in case you want to know more about E closure concept, refer the previous video in series. So we have E close of delta E A comma A. Now what does delta E stand for? It stands for the ε-NFSM's transition, and we very well know that we do not have a state A in ε-NDFSM. Rather it is state 0. Therefore we will rewrite E close of delta E. What is A? It is 0 and A. Now we check this delta E transition, that is on the NFSM. What happens when you are in state 0 and you see an input A? So you are in state 0, on seeing an A you go to state 1. Therefore we will have E close of the transition which occurred here, that is state 1. What is E closure? E closure is of a particular state is all the states which are reachable from that state on receiving an epsilon transition. Now we are in state 1. Here, consider this state. Do we have an epsilon transition? No, there is no epsilon transition which is defined. Therefore, E close of 1 is the same state itself, 1 itself. Next, we'll consider the input B for this start state. Now we consider input B. Input B. Therefore, we have delta D state A on receiving input B. So that turns out as E close of delta E on state A but receiving an input B. Now check for this transition. Now we know that state A is not there under epsilon NFSM. Instead it is state 0. So rewrite E close of delta E 0 comma B and check for delta E transition of 0 and B. Do we have any transition defined? We do not have any transition defined. Therefore it is E close of phi. E close of phi is phi itself. So two new states are formed. So from the start state we had a state A as the start state. Now we have one more state which is defined. We had A as the start state. Now one more state is defined. We'll call it as B. This will call it as B. We can ignore this. Okay. Next we compute transition for this state B for A and B. Input A and B. On A we checked for A and B. We got a new state. Now from B we check for A and B. And the process continues till no new state will be formed. Let us consider state B. We know that we have two inputs A and B, and both these inputs have to be checked for the transitions on B. Now consider input A. Delta D of state B on input A is equal to E closure of delta E transitions. Delta E transitions are the epsilon NDFSM's transition of state B on input A. We rewrite what is state B? It is state 1. Therefore, E closure of delta E 1 comma A. Do we have any epsilon NFSM transition on 1 for A? No. Therefore, that would be E closure of phi. That is phi itself. Next we consider input B. Delta D transition of B on input B is equal to E close of delta E B comma B. Rewriting, we have E close of delta E state 1 and B. Now check the epsilon NFSMs. Do we have any transition on state 1? Yes. And for what input? It is B. And where does it go? It goes to state 2. Therefore we have E close of state 2. What is E close of state 2? What is E closure rather? It is all the reachable states from a particular state when we have epsilon transitions only. So from state 2, which are the states which are reachable on receiving epsilon transitions? See, there is one epsilon transition. This is state 2. On an epsilon transition, it goes to state 3. So this one state. Now 3, from 3 or 2 through 3 can reach 4 because there is an epsilon transition. And again through 3 it can also reach 6 because there is an epsilon transition. Can we go further in this path? No, because it requires A as the input. Can we go further in this path? No, because it requires B in this path. No, we cannot go further. So we can reach 4, we can reach 6. 2 can also reach 9 because there is a epsilon transition. Therefore, E close of 2 is the state 2. Then we've got state 3. Then we've got 4, 6 and 9. Therefore, delta D B comma B is equal to 2, 3, 4, 6, 9 states together, and instead of writing them separately, we will call this as state C. Next we'll consider state C. We know that C is equal to 2, 3, 4, 6 and 9. And for this state, we check the two inputs. So delta D of C comma A is equal to E close of delta E C comma A. Now what is C? E close of delta E C is 2, 3, 4, 6, 9 and A. We can rewrite this. E close of D 2 comma A union delta E 3 comma A union delta E 4 comma A union delta E 6 comma A union delta E 9 comma A. So check for each of these states whether we have a delta transition for 2. On state 2, if you have an input A, do we have a transition? No, it's 5. Now state 3, do we have a transition for A? No, this is 5. On state 4, do we have a transition for A? Yes, it goes to state 5. 4 goes to state 5 on receiving A. So here we can write it as 5. Next, on 6, if we give a, there is no transition which is defined. Therefore, it is 5. On 9, do we have input A? No. So this is 5. So we have E close of state 5. Now we have to check all the states which are reachable from 5 on getting an epsilon input or epsilon transition. So state 5 on receiving epsilon transition goes to state 8 and state 8 goes to state 9. You can see, so 5, 8, 9. From 8 we can reach 3 on an epsilon transition. So 3 is there. From 3 we can reach 4. So 4 is there. From 3 we can go to 6. So 6 is there. So E close of 5 is 5. Then we went to 8. We also can go to 9. From 8 we can go to 3, 4 and 6. So we can write E close of C, E close of 5 is 3, 4, 5, 6, 8, 9. We will call this as state D. Now we calculate for input B. So delta D of C comma B is equal to E close of delta E transitions of C comma B. This is rewritten as E close of delta E transitions of the state C. So state C consists of states 2, 3, 4, 6 and 9. And on all these states we have to check for input B transition. So this is equal to E close of delta E transition for state 2 on B union delta E transition for state 3 on B union delta E transition for state 4 on B union delta E transition for state 6 on B, union delta E transition for state 9 on B. Now we'll see each of these transitions. On state 2, do we have a transition for B defined? No, therefore it is 5. On state 3, do we have a transition for B defined? No, therefore it is 5. On state 4, again no transition, therefore 5. On state 6, yes, we have a transition, we go to state 7, so we can write it as 7. On state 9, there is no transition which is defined, so we can write it as E close of 5 union 5 union 5 union 7 union 5, so that is equal to E close of state 7. Now what do we do under E close of state 7? So under E close of state 7, we have to see for all the states which are reachable from 7 on an input or epsilon transition. Therefore, from 7 we can reach state 8 on epsilon transition. From 8 we can reach 9. From 8 we also can reach 3. From 3 we can reach 4. From 3 we can reach 6. Therefore, E close of 7 is equal to 3, 4, 6, 7, 8, 9. We call this as state E because this is a different formation. Here it is 3, 4, 5, 6, 8, 9. Here it is 3, 4, 6, 7, 8, 9. Therefore, we have two states which are formed. Next, we will consider state D. Now, considering state D, so D is equal to a mix of state 3, then we had 4, 5, 6, 8, 9. Now we calculate delta D transition. Delta D of capital D on A is equal to E close of delta E D comma A. Rewriting D, we have E close of delta E 3, 4, 5, 6, 8, 9 on A. You can split this. Therefore, E close of delta E 3 comma A, then we have union delta E 4 comma A union delta E 5 comma A union delta E 6 comma A union delta E 8 comma A union delta E 9 comma A. We'll see the transition. On state 3, no transition for A defined, therefore this is 5. On state 4, yes, we go to state 5 from state 4 on seeing a A. What about state 5? No transition for A, so 5. Then state 6, no transition, so 5. State 8, no transition defined for A. And state 9, there is no transition. Therefore, we have only E close of state 5. Now, E close of state 5 we have already seen in the previous calculations. That is equal to 3, 4, 5, 6, 8, 9. This is actually state number D itself. Therefore, we will not rewrite or rename it. Next is delta D transition of capital D and small letter b. Small letter b is the input. That will be E close of delta E D comma B. Rewriting, we get E close of delta E. What is D? It is 3, 4, 5, 6, 8, 9, comma B. Splitting, we get E close of delta E 3 comma A union delta E 4 comma A, sorry, this is B. Then we have union delta E 5 comma B union delta E 6 comma B union delta E 8 comma B union delta E 9 comma B. Let us see the transitions now. 3 and B, no transition, therefore 5. 4 and B, no transition, therefore 5. Then we've got 5 and B, no transition, therefore 5. 6 and B, yes, on state 6 if you give a B it goes to state 7, so it is 7. Then state 8, no transition, 5, and state 9, no transition, therefore it is 5. Now the only state, the union of all these transitions will be equal to E close of state 7. And we have seen the E close of state 7 is from state 7 to 8 to 9. From here you can go to 3, 4 and 6. Therefore, writing in ascending order, we get 3, 4, 6, 7, 8, 9. And this we have already seen it is actually state E. If no new state has been formed, and we are yet to calculate transitions for state E. Now we'll consider state E. And what is state E? It is equal to 3, 4, 6, 7, 8, 9. Same process of computing transition. Delta D state E comma A is equal to E close of delta E comma A. Expand E, so that will be E close of delta E. I'll just skip one step and I'll write the states and the delta E transition. So we've got 3 comma A union delta E 4 comma A union delta E 6 comma A union delta E 7 comma A union delta E 8 comma A union delta E 9 comma A. Now we'll see the transitions. For 3 there is no input A, so 5. On 4, yes, we've got one input and we go to state 5. That will be state 5. On 6 we do not have any input on transition for input A. On 7 also we do not have. On 8 also we do not have. And 9 also we do not have. Therefore, it will be only E close of state 5. And E close of state 5 is all the states which are reachable from 5 on epsilon transition. So from 5 we can go to state 8, and from 8 we can go to 9. from 8 we can also go to state 3. From state 3 we can go to state 4, and state also we can go to state 6. Therefore E close of 5 is 3, 4, 6, 5, 8, 9. If I have to see this is state D. Again we consider delta D E comma B. So that will be equal to E close of delta E, capital E comma B. I'll skip one step and write the split up transitions. E close of delta E, what is E? 3 comma A, union delta E 4 comma A, union delta E, again I'm sorry, this is B, this is 6 comma B, union delta E 7 comma B, union delta E 8 comma B, union delta E 9 comma B. Now let us see the transition. 3 and A. Do we have any transitions which are defined? No. Therefore it is 5. 4 and B. No transition. So 5. 6 and B. Yes, there is a transition. Goes to 7. D. Delta E of 7 and B. There is no transition defined. Therefore 5. 8 and B. No transition for B. 9 and B. 5. So this will be E close of state 7. So what is E close of state 7? States which are reachable from 7 on epsilon transition. So from 7 you can go to 8. From 8 you can go to 9. From 8 you also can go to 3. From 3 you can go to 4. And from 4 you can go to 6. Therefore E close of 7 is equal to 3, 4, 6, 7, 8, 9. Or this is state E itself. So there are no new states which are generated. Therefore I'll just rewrite the composition of all the states here. So we have state A. State A is equal to 0. Then we have state B. State B is equal to 1. State C. State C was equal to 2, 3, 4, 6, 9. Then state D. D was equal to 3, 4, 5, 6, 8, 9. And we have E. E was equal to 3, 4, 6, 7, 8, 9. Okay. Now we'll write the transition table. Delta D, we had two inputs A and B. A was the start state. So we have A as the start state. And we knew on an input A, we went to state B and there was no transition which was defined for B. Then taking state B. With state B, we went to, this was 5 on A and C on B. Then consider state C. Now you can see that state C had gone to D and E. Then we had state D. D also went to D and E. And we had state E. E also there was a transition to D and E. And how do we find the final state? We can see that 9 is the final state in epsilon NFSM. So wherever 9 is present, all these states will be considered as final states. So C, D and E are considered as final states. So we'll draw the DFSM for this epsilon and FSM. We've got the start state A. A on receiving an input A goes to state B. There is no transition for input B. B, there is no transition for A, but on receiving B goes to state C. C on receiving A goes to D, and on receiving a B goes to E. D on receiving A remains, it's a self loop, so remains in itself, and D on receiving a B goes to E. State E on receiving A goes to state D, and E on receiving a B can remain in itself. And we know C, D and E are the final states. So this is the equivalent DFSM for the given epsilon and DFSM.